it was built based on in the 80s. So you have a but in order to be reactive, decisions are faster, and what I see is no symmetry between realities and dedicated. I have a lot of points where I would say that the application edge needs to be upgraded and incrementally changed. It was the center of truth and best practice. Yes. It does. So the sheer you know, there's an appropriate solution. If they go to an operator, they will like the Java.
Lutz ist ja something with Bier und Hala, oder?
Ja, genau, hier bist du richtig.
Da müsste ich ja fast
aber
zu dir
nicht
kommen.
mit diesem Hemd.
Du, man hat aber schon gesehen, wo die Prioritäten liegen. Die auf die letzten Mohikaner, weil hier ist natürlich Bier und...
Das geht gar nicht darum. Wir wollten nur das Wort Bier haben.
Ja, genau. Das ist es ja. Das
hat überhaupt nichts mit
das hast du ja vollkommen richtig rausgefunden.
Und guck, ob es funktioniert.
Ja.
Why more people aren't adopting S/4HANA generally, and S/4HANA they wonder why is it given out?
You make a divide in your mind when you put a note on like cloud. If you want to what you actually the divide between on-premise and cloud is not as huge as the divide. Think of a private cloud. What I am looking into is the metal where they have the metal infrastructure, you know, or the networking, firewall, and they take care of the services. That is actually on-premise. That step is still on-premise because the system is responsible for it. So, also ich sage, dass du jetzt auch und jetzt ein Video drauf auf you have to well, on the technical basis, this is not as much an impact as I think. What they say is,
wenn ich das Gleiche mit dem Link noch rüber
they give a discount well for the next 3 years. For the next 2 years. What happens if they drop the discount?
Aber wenn du drauf liegst,
das geht dann auch. Ich glaube, ich mache den Link als Link rein. Und
jeder kann dann da drauf klicken und sagen, okay, I work on this system last year, and I have my own start there and make the adaptation changes. So I have with cloud software. Well, I'm a passenger on the cloud, you know. How do I say it?
On the Titanic.
Yes, on the Titanic. Yes, you're a passenger on the Titanic if you're working with cloud software. You're basically, you have have to continue this ship over. Something is wrong.
Gregor, ist das noch die gleiche URL?
Nee, irgendwie, weil beim Oliver funktioniert, ich habe sie im Wiki gerade.
Okay. Ja, dann muss ich kurz meinen Retweet wieder wegnehmen.
Ja, genau, lösch den kurz nochmal. Und
Kannst du vielleicht einen Tweet löschen?
ja, mach mal. Oder ich tweete jetzt nochmal rein.
Ja, ja. Können wir über den Stream machen, genau. Aber du kannst die Kamera ja nicht drehen. Achso, wir haben das Foto. Achso, das ist mein nächstes Mal. Achso.
So after we received a lot of very interesting information regarding ABAP and ABAP to the future from Paul Hardy, we are now happy to announce Uwe Fetzer, where he shows us some very interesting topics regarding HANA and beer. So in this case, give him a warm welcome. Here's Uwe Fetzer.
Hi from my side. It's always hard to speak after Paul. Don't expect too much humor or, in this case, ABAP. My session is about HANA and beer, and why is it so? This is a story about a presentation I held at my department at Rheinenergie. You see, I'm working for Rheinenergie in Cologne. And the session I hold was, and I don't want to use the bit boring flight data model. I was searching for something others. And you may know I like beer, and so I searched the internet for data, and what I found was, you see, well, what I found was Open Beer Database. Yeah, I was so lucky to find something like that. Unfortunately, it's a bit outdated, so don't expect the newest and hottest beer taste beers in the database. What I've done is to download the zip, and you can see the zip contained some CSV files, beers, breweries, styles, but if we open, for example, the beer database, lots of crap inside. Line feeds in the text or much comments. It was much manual work to clean up these data. But after I've done all the cleanup, we could upload this data to the HANA database. Oops.
We need a proper database.
No, we
Something about IQ.
we just have to unlock the shift lock. Oops.
Go get your link again.
The HANA database has a functionality to upload CSV data and to create the tables on its own, and it's was no problem to create the tables out of the CSV file. So you can choose, if you go the context menu on tables, you can just import data and choose your CSV data, CSV file. It's no problem. You can create the columns and just import the data. If we look at the table where the column names, when we open the data, the define it with some long text, and if you see the ABV, it's alcohol by volume, the alcohol values. What I wanted to do with this data is to demonstrate two aspects of the HANA database. In my presentation, I have shown the four representations of data: the normal column store data, JSON document store, graph databases, and the spatial data representation of the data. I like especially the graph database because I've worked a lot with Neo4j. I also made an API from ABAP to Neo4j where we can upload data to Neo4j, and it's, I think, 4 or 5 years old already. And because of that, I wanted to use now the functionality of SAP HANA in its own graph database functionality. So, what we had to do, there's no whiteboard here, no? No, unfortunately not. What is a graph database? A graph database contains two main tables: the vertices, the objects itself, and the connection between these vertices, called edges. So we had to transform now the many tables we created in the ABAP, in the HANA, beers, breweries, what we have categories, styles. These are all vertices. So we had to combine these vertices into one table with all the objects. How did I do this? You may know my preferred language is Java. Java, correct.
Endlich gibt's das.
Ja, heute kein ABAP-T-Shirt. A bit ABAP. Right, I'm an ABAPer. That's why I've got the Twitter handle SE38, you may know. Fortunately, in the developer edition, ABAP developer edition, there's already the HANA client installed. I've blogged on the SCN about it, you can use your ABAP Developer Edition and connect it with a HANA system in the cloud or wherever. And that's how I combined the object tables into a vertex table. Here's an example where I select the breweries and combine it with the object city. We have the brewery table. The breweries are already in vertex table and combine it with the city table. So at the end we have I've created the edge, the connection between the brewery and the city. And at the end, the result are two tables, vertex and edge. If you look at the table, vertex, for example, we see the types. Is it a brewery? Is it beer? Is it a city? And we have an edge where we combine now the source, the brewery, for example, with the target, the city. We look at the table with the data. See, we have categories, we have styles. And breweries, there are around 5,000 beers in the database now. So, what is a graph database? The graph database is now a combination of these two tables. We go here, graph workspace. The graph workspace now combines these two tables. And if we call here, I've got a mouse. So these two tables, and if we now have a look at the results, we have a lot of vertices now. There's a random chosen set of vertices now shown, 200. We can now label the vertices. For example, we choose a name and the edge is the type. Okay. What can we do now on this graph database? Someone have already worked with Neo4j? No one? Okay. Neo4j has a language called Cypher. And this language is already also chosen by SAP to select, to access the graph database. I have some examples of the some selections. I don't want to type, so I only copy and paste from my source code. For example, we just select one vertex called brewery, where the name of the brewery ends with Bolton. Bolton Brewery is next to my home, and Korschenbruch. The English people, please pronounce Korschenbruch. So we do now have the vertex Privatbrauerei Bolten. We see the vertex is connected with 5 other vertices. For beers and a city, Korschenbruch. Korschenbruch has another vertex, is in country Germany. We now see in Germany we have 84 more breweries in the database. This is really an easy selection of the data. If we choose a more complex example, this is one of my favorite beers, for which yesterday we also tried one or the other. This beer has a vertex ID 4621. In my selection now, what do I want to select? I like this beer. So what kind of other beers are from the same style? So I select this beer. Here one is the Bolten Alt. We have the edge, has style. I select the style. Now I go with the same style with another edge, reverse, select all the other beers with the same style, and select from this beer with the third edge, brewed at, and select the breweries. So we choose the other beers with the same style and select all the breweries connected to this new beer. So we now have the other breweries with the same kind of beer. Most of them are also alt beer. I'm from Düsseldorf, so I've chosen, of course, alt beer. But for example, Tuckstein. It's not, it's brewed in Hamburg, but they also brew alt. It's a really nice beer. One of the problems in the CSV data were also the German umlauts. You know, most of the breweries called Bräu,
Yeah.
or there's a not so good beer called Kölsch. So I have had a program which enters the German umlauts in the beers, or here a Füchschen is also, we also drank it yesterday. It's just for preparation for today, the session yesterday, of course. So now we have one example with a more complex selection. I have some others. For example, I like the alcohol by volume of this beer. Again, the same beer. And now we have a really nice result. We have the 4.9% alcohol in the middle, and all the beers around it with the same alcohol level. This is an example, very interesting. Ich selektiere alle Altbiere. I'm select all of the alt beers and look where, in which brewery the alt beer is brewed, and select all other beers of these breweries This is kind of interesting because this traditional Altbier brewery in Düsseldorf, but there are also many breweries in the United States. And most of them not only brew Altbier, but also, for example, Kölsch. At the end, it's the same beer, but you know. This data model also invites to just browse the data. It doesn't make much fun to start, for example, with a city. We only select a city, in this example, Amsterdam. We see Amsterdam has 3 other vertices, one city, one country, and 2 breweries. Now we can just open the Amstel brewery, look what beer is brewed in the Amstel brewery, Amstel Light, not my kind of beer. Amstel Light has an alcohol by volume of 3.5%, has a category North American lager. Is it lager or lager? And has a style, American style light lager, where 50 other beers have the same style. A double click on this vertex. Now we get all the beers with the same style. We see, for example, this Miller Genuine Draft. What we see in Miller Genuine Draft has a ABV of 4.66% and is brewed at the Miller Brewery. If we open the Miller Brewery, there are all other beers in the city, Milwaukee. We go to Milwaukee and see there are 7 other breweries and so on and so forth. And if we look at the result, it's really absolute fantastic to browse just the data. It's a lot of fun. Now we go back to the tables. Okay. Yes, I know. I close all the graph stuff and open, for example, the table geocode. Geocode. In this table, we have the coordinates of the breweries itself. And we see here a data type called ST-point. Who of you already work with spatial data? Okay. Spatial data, what is it? You can enter the simplest spatial data is a point, just a point. But you can enter also lines or polygons or multi-objects. In this case, I have the point of the brewery. If we select, for example, select this point from where it's I know it, the brewery ID 1018 is the Bolton Brewery. If we now select the this point, and nobody knows what is it. But if we work with a function on this spatial data, dot stx, and the same again with then we see it's really in this column is stored a coordinate. There are a couple of functions defined in HANA. For example, GeoJSON. Anybody here already work with GeoJSON? Okay, so very interesting.
Copy paste into a map.
Huh?
Copy paste into a map.
Copy. Oops. Copy and enter. We are now, here's the Bolton Brewery in Gorschenbruch. Really nice. Really, really nice. So, as I've discovered the function of a GeoJSON. You may know I like JSON. I've already created open source software, ZJSON, and so I've created a new open source software called the GeoJSON. We can create points, or we can create all other GeoJSON objects, and the result is a well-formed GeoJSON. But the result of a JSON, it was not enough for me. I don't want to copy and paste every time into the geojson.io. I want to display directly within from my other program the result. So I searched for a JavaScript library, open source library, which I can use for my purpose, and found the Leaf.js library. It's open source. You can paste the GeoJSON and into this library and get a map with the objects as return. So, demo of this. I start this report. Ta-da! It's plain ABAP. We see Waldorf. These are 1, 2, 3 objects. This is a multi-polygon. It's one object. These are 2 lines, and this is a point. Greetings. Another nice function with GeoJSON is that there is much open data GeoJSON. For example, there is the Open Data Lab, where all the counties in Germany are coded in GeoJSON. You can go into one of these counties. Where are we now? Some kind, don't know. This is a county called Recklinghausen. There's Dortmund. County Dortmund. No, we are in Essen. Now we download this, this as GeoJSON, and I've implemented a function in my GeoJSON class where we can work with layers. So I've downloaded one of these counties, entered this as layer, and this is the result. The layer is Düsseldorf, and I can enter the objects upon this layer. If we look at the code, we see just a couple of lines. I define my point, and I read the other layer from the repository, mine repository. I uploaded this layer into the mine repository. So, back to beer. Now we have these two features. We have the GeoJSON and we have the Open Beer database. Now we can combine these features. For example, we can display all breweries in Düsseldorf, for example. Ta-da! Nice. Or in Cologne. Or in one for DJ, Manchester. What happened now? What happened now? We have also Manchester in the States, but this is there are two breweries in Manchester, and they opened the beer database. I think there are much more.
Try München.
Munich, München. One with umlaut.
Soll it work for Köln?
I think in München is just one brewery entered. Oh, two.
Oh, at least two. Okay.
This is Paulaner and
Unionsbräu. Okay.
Yeah. There's missing an umlaut.
Okay. That's
Not
really
much.
outdated.
Yeah. And there is beer on Hawaii.
Okay,
At least one.
there is beer.
As I said, HANA Spatial has a couple of functions. For example, if we have 2 points, we can simply measure the distance between these 2 points with just a function in the select statement. For example, I have another report where we can ask the system where is the next Altbier brewery from any kind of point. For example, this is my home address. This is my home address. And this is the next brewery. and the next brewery is exactly 10 kilometers away.
Search the next Kölsch brewery.
No, I only have, I select only alt beer breweries. So, if we choose Cologne, we have the next brewery in Düsseldorf. So the 3 kilometers. Or we can select ThyssenKrupp, where we are now. And we see still Düsseldorf. If we now select again Hawaii, no,
Oh.
it's Santa Fe. It's like the 3 brewery in Santa Fe, and it's around 5,000 kilometers away.
And if you're on Wartinger Straße, what's the next brewery from there?
This Füchsen.
Yeah.
I don't need another system for this. but let's check. Wartinger Street in Düsseldorf. Oh, Schlüssel. But I think Füchsen is around here. Don't know why. I have to check. Debug. I think this is it.
Nice.
Questions? Nothing?
Yeah, I have some questions.
Yeah.
What are you actually doing with the Neo4j database? Do you use it a separate instance of the Neo4j database?
Yes, on a VMware.
So you have a real graph model on the Neo4j.
Yes.
So what's the part of the HANA database then?
Nothing. It's just API from ABAP. You can use ABAP with the Neo4j. So it was the time. There was a time before HANA, and that's because that's why I've created this API.
Yeah. So perhaps to be clear, you've shown this now based on the HANA.
This is completely HANA. This, I'm not working here with Neo4j.
It is not.
This is plain HANA.
Okay. I saw some Cypher. Can you make queries in Cypher?
This is completely within HANA. This is the web IDE from HANA, and the Cypher queries were entered in the web IDE, and it's against the HANA database. Cypher is used from SAP because Neo4j open sourced the language Cypher.
Yeah, I know that.
Eine Bitte. Okay, another question, sorry.
Yeah, so did you use a cloud HANA or?
No, it's a HANA Express edition in my company. We have VMware, every instances of all HANA databases and other systems are virtualized, and I've uploaded a HANA Express edition into this data store, into the CVM server.
And you can download that also. So there is a free HANA Express edition, is a free download, and you can use it also commercially up to 32 gigabytes.
Yes,
but with
totally
only community support.
Yeah.
Okay. So at our company, they will introduce S4HANA.
Yeah.
So is the Cypher modeling also?
We discussed it yesterday. No one knows it.
No one knows
it. It is implemented, but not licensed.
Yeah.
We don't know the license.
You have for S4HANA, you have a HANA one-time license to use it with S4, but this is native HANA stuff. Ask your account manager.
We don't know. SAP don't know.
I think it's not recommendable to mix up the things. So you have S4 as S4 database and
Why don't
database.
why don't you want to use the functionality of the HANA database?
Yeah.
You have
Do XSA on top, and you're good, right?
Yeah, it's regarding technically it's possible, but for compliance reasons it could be.
For instance, and to run it in a stable way, I don't think that's a good.
Perhaps a side by side is a better approach.
maybe, but you have to replicate the data.
That's a drawback.
If you want millions of IoT devices and want to know where they are, and you get the data, you already have the data in your S4HANA. Why you want to replicate all this stuff again and again into the sidecar HANA? The data is already there, and you can use the functions of geospatial, for example, on the existing data. So this question is a good question, but we cannot answer it. Yeah?
I have not so good question. Is it possible to display edges in from different for different types with different colors with different
Yes.
information? Because you have one gray.
Yes, I think we go again into the graph database, display, and where we already had select vertex style, for example, type. Here, select color.
Automatically to define types, they have different edges. There are edges to the cities, there are edges to
Yeah. So you can color, for example, cities in green and beers in red, and
what I mean is automatically, not by selecting, but automatically to
from outside. From outside, you
already defined somewhere to use it without giving colors. I just want to use it. I start with one point,
Okay.
and I begin to browse.
Yeah.
So, and I would like to have different colors for different technical things.
You know.
So now
The
gray
beer
lines.
is already in red, and the brewery is in blue, and so on.
I mean the edges.
The edges is no problem again. I think, yes, edge, you can, the type is brood edge, for example, brood edge in green.
Okay, and now the
Apply.
question, can you predefine this?
No, because we are in the web IDE, and the end user will never see this. This is just the graph database at the end just want to give a result, for example, again back to the flight data model. How is the shortest flight from whatever Cologne to Detroit? We have vertices, airports, and edges, flights.
So it's only for developers.
This is, I think, for developers to check the data model. At the end, I want to see numbers or edges. Get me the flights from there to there. This is where you want to get the result in your other code, for example.
And you could not there is a code icon there in the.
This is where I've entered the
okay.
cipher, or get
So
the
it's
shortest path.
not converting that what you
No,
manually
no,
did
no, no,
into
no,
some
no.
codes that you can then save
No.
and to redo
No.
what you now have colored.
No.
Okay.
interesting, for example, is travel. We have, I'm now in the flight data model where we have the airports and the flights between the airports. And if we go, for example, in a procedure, this one, there's a procedure where we select the shortest path between two airports. I'm over time already. Okay, I'm.
I can make a short interruption. You can get in point-to-point discussion now in the networking session for the next half an hour. So we will follow up with the two further tracks. On the one hand side, about who are you from Tristan Haupt, and the results study from DSAG, Dr. Siesemann. We'll continue at 11:30. And so now we can get on point-to-point discussion and go on more detail on this topic. Yeah, thank you very much. Yep. And
Eine Bitte noch, geht morgen wählen.
Just a quick question, or just a quick ask. Right? Gregor and I, we are live streaming the event on YouTube. Right? We are posting the URLs on Twitter. Please, if you have a Twitter account, share this. Right? Make it as widely shared as possible. Retweet. Right?